Hello, am I audible now? Ramesh, can you hear me now? All right. Okay. So, Bharat and Mike, I think you guys had some issue last week. I mean, in the last session, because of which I think you have missed the DNS part. So, I was just wondering, did you get a chance to refer to the DNS part again? So, we have covered DNS with respect to the package called Unbound. So, do you want me to quickly go through this Unbound configuration again? Bharat, Mike, could you please confirm? Or if you're clear, I will move to the next topic. Or if you want, I will quickly go through the Unbound configuration again. Bharat, Mike, are you there? Could you please respond?
Yes, sir.
Okay.
Hello?
Yeah, am I audible?
Yes, sir. We can hear you.
Yeah, I was just asking whether you have got an opportunity to go through Unbound configuration or should I repeat?
No, no, sir. Actually, we were typing the message. So, yeah. Can you please rewind that again? The DNS topic.
Okay, so the package that has been used in order to do the DNS configuration is called as Unbound. Okay, so we are in RHEL 7. We are using RHEL 7. So till RHEL 6, the package that has been used is called as Bind. So Bind basically provides the DNS functionality. So quickly, DNS means domain name server. Okay. So if you remember, so I have given an introduction on the DNS in the last before class. It is a domain name server. The local file, which is etc hosts file, okay, contains the mappings of host name and the IP addresses. So this file basically helps in order to identify the hosts in our network. So the basic means of communication, okay, at the core level is because of the MAC address, which is every system has a uh, network card, right? So this network card will have MAC address first, on top of which we will assign IP address. So we usually consider IP address as identification for every device in the network. So devices communicate with each other using the IP address. So other than the IP address, we also provide the host name. Inside etc hosts file, we maintain the mappings of host name as well as the IP address, right? So this is the simplest form. You can see here, right? So these are the mappings. Now, if you are connected to the World Wide Web, this file is not sufficient. So you might have to request a service in order to provide these mappings for you. That service is called as the DNS service, domain name service. So since it is not so easy to remember the IP addresses of all the services which are available over the World Wide Web, we have this service called DNS that helps us in resolving these IP address to host name or host name to IP addresses, and it will allow you to reach that specific instance, which could be present anywhere in the World Wide Web, and in order to make use of that particular service. So service could be a web service, or it could be a mail service, or it can be any kind of service. So there is a website, or there is a blog that you wanted to access. Okay, it will be hosted on a web server. So a HTTP service basically hosts all the web pages. So if you need to access, if you want to access a particular web page, you need to reach out to that web service. So it will be hosted somewhere outside in that particular server. So you need to reach out to that server. Now, we know that you might have heard about different kinds of domains. You can imagine the World Wide Web as kind of a root structure, which the top most level folders are like, the .com is one of the domains. So under which there is a tree structure, .in, .co.in, and .co.uk. So there are different kinds of domains available. So first of all, when you are doing a request, it will check for the corresponding domain, whether the request belongs to that branch or not. Okay. So some pages, if you have observed, when you try to retrieve, they'll be very fast. The moment you hit, you will get the page. Some pages might take a little more time. Okay, a fraction of more time. So that is because, so whenever we are making a request, the request first goes to the local DNS server. That means the ISP provider will have the DNS server. So it will check. This DNS server maintains a database of the information, and it also maintains a copy of the web page that you are requesting for in a local cache. Okay, so that's one of the category of DNS servers are also called as caching DNS server, or we also call it as caching name servers. So so what happens is, if it has that requested information, the web page that you have requested for, it will immediately give you that web page. Or what it does is, if it doesn't have, it will go and look for the same page in another DNS server. Okay, so these DNS servers which are there, they are also spread across the World Wide Web, okay, in such a way that every DNS server acts as a master as well as a slave, or a master and slave. That means, imagine this inverted tree structure. Okay, when you pick one DNS server in this entire tree structure, so if there is a DNS server above that hierarchy, then it acts as a slave. If there is a DNS server below its hierarchy, then it acts as a master to that DNS server. Okay, it's as simple as this. So it acts as both master and slave in that context. So here what happens when you are requesting a DNS server, which is your ISP provider for some information. Say your ISP service provider is limited to your street, or to a bunch of streets. Okay, if he doesn't have that, what he'll do is he'll he'll route that request to his master. Master here could possibly be a DNS server which is configured at a city level. Okay, for all the DNS servers which are there in for every bunch of street, there will be a DNS server for the entire city, and above that there could be a DNS server at a level, and then state level, and then country level. So like that goes each level above the hierarchy. Okay, and possibly this hierarchy could be part of, again, a .com or a .in or a .co.uk. So at some point, the DNS server would route your request to, for example, if it belongs to .com, it might be routed to that hierarchy, and somewhere in that hierarchy, it would figure out where your actual web server is present, which is hosting this web page. Okay, so if you have observed, when we configure a service locally in this instance, for example, so these are all private IP addresses. I'm configuring it on my local machine. So the moment I configure in my local machine, uh, the related information gets stored in my local machine, right? So once I make my IP address public, so this information would definitely go to the nearest ISP service provider. So that is how the actual web service information will be part of the nearest service provider, which is present somewhere in the tree structure. So all the requests have to reach that machine, and when you are retrieving this information, okay, the rest of the DNS servers, what they do is they will maintain a copy of that information, so that if a request comes again, they can quickly retrieve the web page. So rather than going through all this path again, so they will retrieve the information. Again, you might have a question that how many such requests can this DNS server will store, because there can be too many requests that happen in the World Wide Web. Too many people are performing too many requests. So for that, so there is something called there is a parameter. I mean, the DNS server will maintain the cache, so will keep that web page in its cache for a specific period of time. Okay, so it will check for the number of repeated requests that keep happening for that page. So if it is part of the requests that keep happening often, then it will maintain it, or beyond a period of time, if requests are not coming to the particular web page, then it will remove such kind of pages from its cache. Okay, so the requests are there, then it will not maintain it. So there are some configuration parameters that can be done. So with respect to the course that we are going through, we will just restrict ourselves in order to configure the basic cache only DNS server, which is unbound. Okay, so usually with respect to DNS services, remember all this is tree structure, and there are specific top level DNS servers which are for .com, .org, like that, and each DNS server performs as a master, as a slave. Okay, there is one above and below. There are different types of DNS servers available. So we are going to only deal with caching only DNS server or a name server. Basically, a DNS server provides the resolving functionality, IP address to host name and host name to IP addresses, and it would also maintain the cache of the requests that we are making. Okay, so Unbound is the package that provides this functionality. Prior to L7, bind is the package that we were using for this particular functionality. Now coming to the configuration part, so here as you can see, the configuration is pretty simple. First of all, we need to install the package called as Unbound. Okay, so there are no dependencies. Systemctl start service, systemctl enable it to make it available along with the program. There are a few changes that needs to be done inside unbound.conf. etc unbound.conf is the configuration page. Okay, so inside this, so you can make a note of these changes which are here. So these are the so 10 lines. So this information is already present inside the configuration file. It will be commented. You have to remove the comments and make slight changes. Okay, so 1.11 means this is the IP address of your system where you are configuring the DNS server. Okay, so access control 0.0.0/0 allow means so we are requesting to allow all the instances present in our network to query our DNS server. Okay. Similarly, we are going to enable the TCP and IP4 related requests, TCP UDP. Where log unbound is the log file. So whatever you define here, okay, so where log specify the name of the file, automatically the corresponding log messages would go to this file. It will create this log file and it will start updating the logs inside this log file. Okay, and finally, one of the forward address is 8.8.8.8. Just remember, there are these are Google DNS servers. Okay, one is 8.8.8.8. There is another one called 8.8.4.4. So sometimes, if we also update our name server using these IP addresses. So in case the local DNS server is unable to perform this resolving property, we also add the Google DNS servers which are reachable. So that's what we are adding here. Okay. So once we make these changes, we also have this command unbound-checkpoint. So you remember we performed a similar check for Samba service, I guess, to quickly check whether changes have been properly made inside the configuration file or not. In case if there is any syntax errors, it will help to print those changes. Okay. So and then systemctl restart unbound service, and as usual, the firewall command is where we have to add the DNS service to the existing firewall, and then reload the service. Once this is done, what you can do is you can quickly perform a drill. Here, if you observe in this section, okay, so what we are trying to do here is, okay, so there is a command called drill. Though we have not covered drill before, we have done ns lookup, we have done dig command before. So these commands would help you to quickly connect dig. So google.com. Just one second. Okay, so let me explain this first. So in this command, what we are doing is we are trying to perform a drill operation. That means it is going to quickly send request to the DNS service. So here, drill @developer.co space @IP address. This means, so we usually do this, right? So ping space some website. So the request will go to that website, it will send some packets. It's like the response which is there, it will take it and it will show the time interval, how long it took to respond, whether the site is reachable or not, right? The same thing here, what we are doing is we are trying to route that request through this particular DNS server. By default, inside our resolve.com, so that is where the name server information is present, right? So whatever request that you are making, it will first check the name server is going to resolve that request for you. So here it is 192.168.1.1. So that has resolved that request, and then it has to check for this particular website, whatever you provide. So here we are making that request to go through this particular DNS server. Okay. Rather than going to resolve.com, make use of this DNS service. So that is what this command is. So similarly, we also use commands like dig and the other one that I have mentioned before. So we use those commands also. So once the DNS server is configured, from a client mention, what we can do is we can update. So in this example, 1.11 is there. So this is the DNS server. So on the client side, simply open etc-resolve.com and then update this information. Okay, and whatever request that you make from the client side, here you can see. So this is the client side configuration, DNS client side. Okay, so now whenever you make a request, okay, so at the bottom of this request, so this is the dick space Quora.com, and at the bottom it will give you the query time that has been taken and what was the DNS that has helped you in order to make the query. So this is the information. Okay, so when was the request made, what was the time taken, what was the DNS server. So remember the port number, the default port at which the DNS server works is 53. Okay, and typically this is how the output would look like when you perform a dig operation. Okay, and this is a DNS client side operation. So it basically provides the corresponding records which are part of the DNS cache. So when we say DNS, the records or the mappings of a particular request that we have made. So what are those mappings means? It maintains these records. Okay, so usually we call them as the forward map and the reverse map. Okay, that means you can perform a DNS lookup using host name as well as IP address. You can say dig space Quora.com, or you can also say dig space -x. You can give the IP address and perform a reverse lookup. Okay, so you can query both the ways. So that's why we split them. So DNS maintains them as two different records in two different zones: forward lookup zone and the reverse lookup zone. Okay, so like this. So here, as you can see, so this instance has been used as a client in the last class, and we did dig AOL.com, and it went through a DNS called 192.168.1.2. Okay, so this is how I have configured the client. I just updated name server as 192.168.1.2. So here, let us consider this as an example, an exercise. So if you have been, I guess you are following me throughout some time, right? So my I'm unable to connect to internet, okay, because uh, till yesterday my uh, router IP address has been configured in the format 192.168.1 network. Okay, that is 1.1. So I've configured my instance IP addresses in a similar format. So I did 1.125, 1.22. So that was the format I've continued, and suddenly, well, because of a change in the router or place, it has taken the format 192.168.0.1. You can see here. Okay, and the corresponding subnet would remain the same, and accordingly for my Windows in the laptop, for Windows OS, it has given 0.5 as IP address. So because of this change, I was unable to connect to the internet from my Linux instance. So sometimes you might, in case face this error, what you have to do is go back to your configuration file and update them. So update the resolve.conf as well as your FCLG network configuration file with that format 0.0.1, 0.1, and restart your network. You should be able to connect to your network once again. Okay, so just ensure that we are in sync with the IP address format for your router. Okay, so sometimes it might also pick the range, which is 10 dot range. Remember the ranges that I've mentioned. So there are two private IP address ranges that are available. One is 192.168. That means it can start from 0 dot, it can start with 0 or 1 dot something. Okay, and some networks, some ISP providers, they give you the 10 dot network. So your IP address or your router address and the local instance. That if you look for DHCP IP address, you get the 10 dot IP address. In that case, you have to configure your instances with the 10 dot. They should be part of the 10 dot network. So you need to configure accordingly, and just look for your Windows IP address because it gets it dynamically using IP config. Here you can get the subnet mask, okay, the gateway information, and then the IPv4 address is the IP that has been allocated to Windows. Just you can increase this number and assign in that range for your Linux instance. Automatically, you should be able to connect to that network. Okay. So yeah, so here if you observe, so this is the typical output of the dig that we have done, dig google.com. So these are all the records that are maintained for Google. Google has multiple, server engines available which are hosted on all these instances. Your request can go to any of these instances and give you google.com page. Okay. So that is how we test, and here it is again, if you observe, it is going to 0.1. Similarly, you can update the resolve.conf file or use this particular command, which is the drill command. Okay, and make sure that the request routes through that particular DNS server, or you update the resolve.conf with the new DNS server that we have configured, and then you can test the client using that. Okay, so that is about the DNS service. Now we will proceed to the server configuration. Yeah, just another example. I told you that we can perform both the kinds of lookups, right? Forward as well as reverse. So here, if you have to dig using the website name, and then if you want to do a reverse, you can do dig -x or give the IP address of the machine. Okay, take one instance or take the output of the google.com dig request we have made. So you can dig google.com, dig -x, put the corresponding IP address and perform the same operation. You would find the reverse addresses. Okay, so usually they are this format. Starting the convention is this IP address dot in-addr dot arp. You would find reverse lookup records in this format. So this output which is there that you get when you do a dig, okay. So this output will have 5 different kinds of sections. The header, the question means the request that we have made, and what was the answer that we have got from the corresponding DNS server, okay. And then who is the authority. So as I said, if you remember, there are different kinds of DNS servers. One is cache only server. Another kind of DNS server is called as authoritative DNS server. Okay, so here it provides the section like you use the authoritative DNS server responsible for making this request. Who contains this information, who has provided this information, and then additional information is about the amount of time taken and all these details. This is the last section. Okay. All right, so that's pretty much about DNS service. Now we will proceed to another service. All right, let us keep you on mute for 2 minutes, and we'll get started in 2 minutes. Okay. All right. So can we get started? Hello everyone. Please confirm if you can get started. Or if you're in a break, I will wait for some time. Okay. So the next topic is about so okay. So I hope I have not covered web server configuration so far. So most of the things that you see over the World Wide Web, they make use of Apache configuration. Apache in general is a group or an organization that provides a lot of open source softwares that are available. And Apache web server is one of it. Okay? So 90% of the websites that are configured across the globe to make use of the standard Apache configuration. There are other service providers like we had Bind and BOM. We also have other uh, service providers who provide the corresponding software for configuring a web server. Okay. Now, in this case, we are going to use the Apache configuration of the HTTPD service. So, in order to, so I hope you understood what Apache configuration is. So, you basically install the service. This service basically helps you in order to post the web pages on your system. So, these web pages are accessible in your network. Okay, and if your IP address is a public one, then your web pages that you have posted, okay, they are accessible across the globe. So anyone can hit your URL and look at the web pages. So web pages are also of different complexities, right? From the simple one, the simple HTML pages, okay. So you can pick any web page from the internet, click on the right, just right click, and you can look at the page source, right? So there you can see nowadays there are different types of languages that are being used. But here at least you can see the basic HTML tags that are being used in order to uh, write these web pages. So this is how HTML content is developed. So there are both web pages and dynamic web pages that are available. That means, so dynamic web pages are those that will uh, generate the content on the fly, okay, and it will display on the screen. Simplest example is, for example, in the web page, okay, so when you need to see the date and timestamp over there, so that information you cannot hard code it. You need to write some function and you need to generate it. For example, you need to use something like a JavaScript, right, and corresponding function inside, or a lot of languages are used that mixed along with the HTML content, and those functions will help you to generate dynamic content. Okay, so that is how this simple overview of these web pages. So these web pages are posted inside these web servers, and whenever you try to access, then the corresponding web page will be displayed to you. Okay, so moving forward, so how do we configure these web pages? So all the topics that we have covered so far, like with respect to starting the service, stopping the service, the port numbers that are being made use by the service, okay, all the firewall information. Everything remains the same. The only extra thing is, other than configuring the HTTP configuration file, we would also be adding the HTTP web pages. Okay, the web pages in a specific folder for the Apache service. Okay, so we will go through that information now. So first of all, I just remove the packages which were there. Now I'm going to install it again. Remove HTTP. And as usual, system.utl will enable HTTP service, and then restart and the status. So it is successfully running in the system. Now, in order to check whether it is successfully running or not, we have to hit the local host. Okay, so for that, there is this command line browser called as Linux, which is already installed. Otherwise, you can install the same, and you can do this 127 or simply use local host. So you have to find this page. Okay, so this is the welcome screen for Apache. This page says that the HTTP service has been successfully installed in the system. Okay, and it also provides a lot of additional information. As you can see, it says, are you the administrator? You should add your website content in the directory where www.html. So press Q to get out of it. Here, and then you need to go to where www.html. So this example, I think we have already seen before, right? How to start a simple basic web page. So once this is done, etc httpd on httpd.com, and here there is a directive called listen directive, where we choose the port number, which is 80. It is also possible to bind the IP address as well as the port number. So when you do this bind operation, what happens is you can also hit the IP address and fetch the default Apache or the web pages for this particular instance. Okay, so that is what the binding is all about. So that is the basic testing that you will be doing. So once that is done and the HTTP service is working fine, so some more additional information is the other related packages are HTTP tools and HTTP manual. Okay, and there are two different types of services. One is secure, another one is unsecure. So this is secure one is run on 80, and the other one is run on 443. Now, when it comes to HTTPS, though we don't go with the configuration, but I will provide you some information. So, if you have heard about OpenSSL, so OpenSSL is a service. Okay, so using OpenSSL, so if you have installed OpenSSL in your system, okay, let me see if it is there. OpenSSL is a service that provides some tools or utilities using which we can create certificates. Okay. Certificate. Maybe you might have observed that when you try to access some websites, it would say that the corresponding certificate is is not valid or it is not properly signed. So all this information you would find when you access some websites. It would say that accessing this site may not be secure because the certificates are not properly being traced. Okay, so like that, OpenSSL is one of the service using which we can generate the certificates. And what these certificates are, when you are basically communicating in a network between a server and a client. Okay, so along with the data, they try to validate the information using the certificates on both the server and client side. Remember the passwordless SSH that we have configured. So there we have made use of the concept called public and a private key. We have created the keys and they are encrypted. So before transferring the data, it will validate the keys on both the sides. Similar to that, we have the certificate concept as well. So when communicating over the World Wide Web, okay, in order to make the communication more secure, so we use this concept of certificates. Okay, so whenever we try to connect to a server, so internally it will validate the certificate that the server issues. So those certificates are two types. One is like the self-signed certificates that we generate for testing when we are configuring the services. Another one is the, publicly available. So there are some organizations like VeriSign, right? So these are the organizations that provide the valid public certificates that we have to purchase and make use of for our HTTPS websites, the secure websites that we use across the World Wide Web. So when we are configuring HTTPS, we need to either go with OpenSSL, create a self-signed certificate. So in case you're interested, you can go through the process. It's going to be a few steps. So you have commands called OpenSSL in which you need to create a self-signed certificate and make use of that certificate and configure the HTTPS service. Okay. So that is too complex. That is too big to cover in this course, but I would like to provide you that information. So we'll restrict ourselves to port number 80, which is HTTP, but for HTTPS, just remember about OpenSSL creating the certificates that are necessary to complete the service, complete the configuration of the service. So we have two different files. One is epconf, .conf is the configuration file. So by default, when you install it, you may not insert config file, but you can get it from the user share docs HTTPD location. There will be a sample file. For every server, you would find a sample file in that location that you can copy it from there and copy it to the main config file. Okay, and as I said, all the default HTML pages, they have to go to our www location. Now the configuration. Okay, so first one is the listen directives. So the entries inside HTTP call them as directives. So by default, either you can have it listen at port 80. This is not binded to IP address, but if you want, you can bind it this way. So once the changes that you want to make inside the HTTP service are done, again you can restart the service, and we have this command called httpd space -t in order to check whether the syntax is right or not. Okay, whatever changes that we make inside the config file, we can cross-check them using httpd space -t. And again, this step is common, adding a firewall. So add service HTTP. If it is HTTPS, we add it in a similar way. is equal to HTTPS. Or if you want, we can add port number 80 as well as port number 443, that would in turn, that would in turn add the service to the exist. Don't forget, reload the changes once you are done with the firewall service. And then you can test the same using ebuild. If you are in a graphical mode, you can try using the normal browser. Otherwise, we have the text-based browser. Alright, so this part is something that we have already covered before, how to perform the basic Apache configuration. Now we will go through a little advanced concept where we are going to change the default location of the web pages. Okay, that means by default they are configured under var www. HTML contains the HTML pages. Say for example, we want to change the default location to a folder called /web. Okay, by default SELinux is enabled in Red Hat 7. It is not possible to change the default locations like that. SELinux will not allow you in order to perform such kind of changes. You cannot simply change the port number to a different port, though we have the option to change the port number. So SELinux always goes with the default changes that are present in the system. Okay, so if at all you want to make changes to those things, then we have to change the corresponding SELinux context as well. Okay, so that's what we are going to see now again. So with respect to HTTP service, so the default folder is var www HTML. Okay, and we want to replace this default location with a different location, which is like /web. Okay, so here you can see that directive where the default location is configured, that is var www. In order to update the same, what we do is quickly go to the document root location, comment that line and create the same line again and change the path to /web. Okay, so first on the changes that have to be made inside the HTTP configuration file. So these changes can be used. These you can also make these simply disabling the SELinux. So if SE enabled, just making the changes inside the HTTP config file are sufficient to restart the system and pick the web pages or start the web pages from the new folder that we have created now. Okay, so I'm just telling you what changes needs to be made inside HTTP. Then we will see the changes with respect to SELinux also. So inside the HTTP, by default, this location is already configured var www HTML, and we are changing it to /web. So update the document root, and at the same time there are other directories that are present. Directive. Okay, so copy those 4 lines here as it is, and you need to comment on those lines. Keep this available. Say hello override. We are granting permissions. Okay. Now, with respect to SELinux, as I said, there are 3 different types of contexts that are available, right? And we will restrict ourselves to the role, the type-based context. Okay. So we are going to quickly check the context that is available under var www. So all the default files and the processes will have the corresponding service range that will be present in the system. We need to check the context and configure the same for the newly created location. Okay, so here as you can see, verifying, we are using this command called scmanage, and this is a typical regular expression that helps to set up SELinux context for all the files and subdirectories that are present for /web directory. Okay, so sc manage f context -t, and that is the type. Okay, for this particular type, I'm going to set up the context for this folder as well as all the subdirectories. So once that is done, use another command called restore con. Okay, so these two commands are important. So restore con -r -v for the folder called /web. So once that is done, so these are the changes. Okay, the normal changes that you make inside the HTTP config file, and then with respect to SC Linux, remember these two commands. One is restore con, the other one is sc manage. Now sc manage command, you need to check whether it is available or not. So before trying it, okay, if it is not available, you need to install it. So that is the normal process. I hope you are familiar with now. So checking whether the command is present or not. If it is not available, how to check the corresponding package? Okay, let me ask this question. Say command is not available. How do you check, or how do you install that particular command in the system? So how do you check the name of the package that provides that command? Come on, it's a simple question. I'm expecting a quick response. How do you check the name of the package that provides that command? For example, sc manage is there. One of the answer is rpm-qa grep package name. No, my question is there is a command. Okay, this command is provided by a package. Okay, so when you try to install using the name of the command, it will not get installed. The package doesn't get installed. You need to install using the package name. So my question is, if I give you the command and ask you to tell me the name of the package that provides the command for you, how do you know that? Okay, more specific. So it is like ask yum about the package name. You need to say provides sc manage, provides sc manage, or yum provides sc manage. Then yum will check the name of the package that contains sc manage command. Then you need to install that package. Then install that package. Okay, so that is how you have to install it. So once sc-man run the sc-manage and boost the content, and then you can access the new directory and the corresponding HTML contents. Okay, with respect to Apache service, so there are two things that we have covered. One is the basic configuration to test the connectivity, and the next one is we've also seen how to bind the IP address and copying the HTML page to the default directory and displaying, trying to access the HTML content. And then, so this is the main actual configuration part that we have already seen before as well. So in order to get the content displayed from a new location, we have to create that folder, put the HTML pages. For example, /web is a new folder that we have used now. So copy the HTML pages to the /web folder, and then update the HTTP config file. Right. So wherever you find var www.html, replace that with /web folder. Copy the corresponding directories like the document root and update it with the new folder name. Okay, and then restart the HTTP service. Check the syntax using HTTP /t, and then apply SCLinux context to the newly created folder and the content by using sc-manage and restore commands, and then try accessing the service. Okay. So the next one is virtual host configuration. So virtual host configuration is where we are going to name the virtual host that will be hosted from our machine. That means we can have the same IP, but we can configure different machines. And this I have also covered this before. So we can say websites 1.7, and we can host both these websites from the same Apache source. Okay. So in order to configure the virtual hosts, so as you can see here, there is a default set of parameters that are there. They are available as a part of your configuration file, HTTP configuration file. So you just have to copy this if you want to configure multiple virtual hosts. So copy it multiple times, and you need to provide the virtual host name and what is the location trying to source the content, and then what is the corresponding log message, and also the information, error message, and the basic information. You need to provide it as a part of the virtual host application and restart the instance. Then you should be able to access both the different websites. Internally, we know that there are two different virtual hosts that are being configured on the same instance, on the same host. The process, but we need to update the corresponding directives with that information. Okay. Now, this is another different example where we can host a very simple CGI application. So when it comes to CGI application, what it means is, as I've said, we can also generate dynamic content, and for that we can make use of JavaScript, or we can make use of Perl scripts. This is the simplest example of a Perl script. Okay, so there is a location called where www.cgi-info. So this is the location from where we are going to copy the CGI scripts that we want to run as a part of displaying the web page. Okay, so here this is a simple example. So copy it inside the Perl script. Okay, and I'll just show you. Let me just create this. Generally, name it anything, .pl. So PL is the convention for Perl scripts. Okay. Shebang operator, and user training Perl is the location of Perl script. Just like Bash, you also have Perl interpreter. Okay, if Perl is in, so we have Perl in that location, and these are like echo statements in Perl. We'll just print line characters. So generally we execute the Perl script this way. So it's here whatever you so it is we are creating the HTML content and also keeping some logic inside the Perl script. So you just have to copy the Perl script to the CGI build location. Okay, and then provide the necessary permissions. We are not going to execute it manually, just for your understanding I showed you that. So then we have to enable the corresponding SCDMX context, and there is something called booleans with SCDMX. Okay, so booleans are like on-off switches. So with respect to every specific functionality, we have booleans available. We have to enable that boolean in order to get that functionality. Okay, so with respect to CGI scripts, so this is that boolean get SCBool httpd underscore enable underscore CGI. Okay, so that you can simply run this command for get SCBool. I can say check all the booleans that are available in the system. Okay, and from this list we can check for CGI. So http enable underscore CGI. This is on. Okay, so if it is off, we have to enable. So get SCBool http underscore enable underscore CGI. Okay, so once that is enabled, you can simply hit that complete URL. Okay, so as you can see, so it is going to get displayed. So this script is executed on the browser and it will display that information on the screen. This is one example of where we can dynamically generate the data. Okay, and so the question that I asked, SCManage is available with this particular package. SC troubleshoot has been server. Okay, so that's pretty much that I want to cover for HTTP service. There is also one additional feature that I will cover, which is about changing the default port number, how to change the default port number for a specific service. That is something which we will also cover with respect to a particular service. We'll take one service here as an example, and we will see changing the port number, trying to run that service on that specific port number. Okay. So any questions so far? We have we are almost close to the end of the course. So we have few more topics, like we will go through the SCDMX part in general. We go through the firewall concept and a few more loops which are part of shell scripting topic. So that is pending. And I think that's pretty much that is pending. You would also be having an exam at the end of the course. I hope you are aware of all those information. And I'm not sure how well you have prepared so far. So let me know if you expect me to repeat any of the topics for you. Let me know in advance if you want me to cover anything again. And so any questions so far, guys? Could you please comment? Okay. Can we have a quick chat? Can all of you unmute here? I just want to ask you, like, how familiar, how good are you with the concepts that we have covered, or the course that we have covered so far? So what are the areas that you think that you are very comfortable with? What are the areas which you feel that you have to practice more? And what are the dry areas that you feel that you have to focus more, or you might need some help? Can you just answer those things? Maybe one after the another. Come on, you should be able to. Correct? Right? Ramesh. Please answer first. No one? Okay, I just saw a message. Practice on the firewall changes and networking. Okay. So with respect to firewall changes and networking, I definitely wanted to focus on configuring the IP address first, setting up your network. Okay. And yeah, it reminds me of the IPv6 configuration. So we will see IPv6 configuration. Okay. So I want you to be very clear on how to set up basic network, how to have a network having some instances, which are part of the same network. You should be able to communicate with these instances and setting up. Just go through those ranges for the private IP addresses. The 10.0 network, 192 network, the 10. So 192.168.x.x. So you will have a common gateway that is 255.255.255.0. Okay. So try to do it this way. Take two instances. Okay. Set up 192.168.1. Then try to again change that to different network and see whether they are communicating at least the two private instances. Also try to add a 10. Network. For 10. Network, your subnet mask would change. Okay, so check that as well. So that way, start and try to finish the IPv4 concept. So it is going to be your resolve.conf and the network configuration. Okay, these two are important. Then coming to DNS, the local DNS is RETC host file that you can check by filling with the host name as well as the IP address. And with respect to unbound, just follow the steps. It's very very simple. When you compare it with the bind configuration, so you definitely find it as complex. Unbound is very simple. Okay, so try unbound configuration as well for all the server concepts till whatever that we have seen so far. So the firewall, setting up the firewall is same. We have been using the same command. Firewall permanently add service called as this, right? So just I hope that command is clear for you. And then with firewall -cmd reload is the command that we have used. These are default for everything. Okay, we'll go through more of those areas in the next class for the firewall concept. But these two lines you should remember all the time with respect to every server configuration. These are the two lines that I used. Okay. And then with SC Linux, you don't need SLNX related changes with every server because we usually stick to the default configuration. Mainly you might need it with a HTTP service, and yes, you have to make SLNX related context changes. So I will give an introduction and explain you more about SLNX. Then you might have a better sense of how SLNX works. Okay, so that's pretty much for today's session. Go through the HTTP configuration as well. Okay, and we'll go through the rest of the topics in tomorrow's session. Okay. All right, everyone.